RHS Pre-calculus presents Gotta Dance, Understanding Inverse Functions.
Hey, I need to figure out how I want to choreograph for my next dance recital. Can you help me?
I think you should do the sine, cosine, tangent. It's the hottest dance nowadays.
Whoa, maybe I can mix it up and do the arcsine, arccosine, arctangent dance.
That sounds a little risky.
Let me show you how it's done. Drop me a beat. Okay, maybe not. Let's get to work. You know what a sine graph looks like, right?
Duh, I'm the king of the sine dance. It's like the worm.
Pshaw you are. Pshaw it is. The standard sine equation is y equals sine x, where the x and y coordinates are x comma y. On graph paper, the x-axis counts by radians. For example, pi over 2 or pi. Its y-axis counts by whole numbers, -1, 0, 1. At 0, the coordinates are 0, 0.
So that's what I've been doing.
Pshaw you have. Let me show you how the arcsine dance looks.
Sweet! What's the math behind the dance?
The equation for an arcsine dance, or graph, but graphs are hardly important compared to dancing, is y equals arcsine of x. The super important differentiation is that the coordinates are the same for the sine graph, except that they are flip-flopped. They are y comma x instead of x comma y. In the sine graph, some of the points are negative pi over 2, -1, 0, 0, and pi over 2, 1.
Wait a sec. How do you know when your dance is getting too out of control?
A sine dance is a function and is continuous, so I can see where you'd have concern. An arcsine dance is also a function. However, when we invert the graph, we need to shorten it so that there are no two y values for each x value. Thus, the range of an arcsine dance and graph is negative pi over 2 to pi over 2, including both as possible values, which is where the sine graph doesn't repeat any y values.
So what's the domain?
Oh yes, the domain, or the x values, are greater than or less than to -1 and less than or equal to 1.
Show me the dance again. I understand. So what's the arc cosine dance look like? Sweet! Sorry to make you talk about math more, but what's the math behind that one?
It's pretty much the same as the arcsine graph in figuring it out. The equation is y equals arc cosine of x. If you were to draw a cosine graph, you would look at the section of the graph where it can be a function. The domain would be x is greater than or equal to -1 and x is less than or equal to 1. The range would be 0 to pi, including both as possible values. Then you take those points and invert them. For example, you would take pi -1 and change it to -1 pi. The graph of the new coordinates would have those values, ultimately creating the arc cosine graph, and more importantly, the dance.
Whoever thought that math could be so fun?
Yeah, who knew?
Can I try to guess how to do the arctangent dance?
Sure.
Woo!
Wow, nice.
The math behind it is quite simple. The equation is y equals arctangent x. For the regular tangent graph, there are asymptotes at negative pi over 2 and pi over 2. That will be a function. You take that segment and switch the coordinates xy to yx. Draw a whole number as x-axis and negative pi over 2 to pi over 2 as y-axis. The asymptotes will be at y equals pi over 2 and y equals negative pi over 2, making the range negative pi over 2 to pi over 2, not including those two values. The asymptotes cause the domain to be negative infinity to infinity.
Oh, that was complicated. I thought you didn't know the math behind these things. That was one of the hardest of the 3 arc graphs.
What can I say? I was born to inverse.
Gotta inverse.